Hello, young grasshoppers. Thank you for accepting the challenge of solving rational equations. I hope you guys are doing awesome. So we are kind of nearing the end of this particular unit together. And so far, everything we have dealt with has been talking about rational expressions. And so we've talked about simplifying rational expressions and writing equivalent rational expressions. And then we multiplied and divided rational expressions, and then we added and subtracted rational expressions, okay? Today and the next lesson, we turn our attention to rational equations, okay? So now I have an equal sign. I've got stuff on the left and stuff on the right, and now I'm looking for the value of x or a or y, whatever the variable is, that value that makes the statement actually be true, okay? Now, if you understand one concept today, I think the rest of this is going to be fairly easy. And this is the concept I want you to think about. If I said x over 3 equals 5 over 3, make it nice and easy for you, okay? If I said x over 3 equals 5 over 3, I would want you to tell me, hey, x has to be 5 because they're both over 3 on either side. And so if they're both over 3 on either side, they need to say the same thing if there's an equal sign here. So the only way to do that is to have x equal to 5. So here's the premise. Once I have the denominators to be the same on both sides of the equal sign, I can just pull my numerators out, okay, and solve for my numerators. All right, so with that in mind, let us talk through just some of the steps together. And I'm hoping that these steps are going to look super, super familiar to you and that they're going to feel pretty darn comfortable, okay? So first step, factor. That's always been our first step, right? We've always wanted to factor first. Factoring makes the world go round. Then we're going to state our NPVs. Then we're going to determine the common denominator for the equation and write each term with that common denominator, just like we were adding and subtracting. Okay, simplify each side of the equation to a single rational expression. Then equate the numerators of each side. Sorry, that's a typo. That should say numerators. Solve for x and then check for any extraneous roots. So with radical equations, we ended up, we always had to plug it back in and verify. We don't actually have to plug it back in and verify with rational equations, but we do have to make sure what we just solved for isn't actually an NPV. Okay, that's what we have to be careful of there. Okay, so let's give it a try. Algebraically solve the following equations. I've got 10 plus 2 over x equals 8. Okay, so first thing I'm going to do is factor. There's nothing to factor there, so that one's done. Yay me. Second thing is I need to state my NPVs. So x can't equal 0. Now, I want to write everything as a common denominator, which means I want everything over x. So this 10 here, I'm going to multiply that by x over x, and I'll have 10x over x. And this 8 over here, I'll multiply by x over x, and so I'll have 8x over x. Okay, so just for clarification, that's like over 1 right now, right? I want it to have an x, so I can put an x on the bottom and the top, and now I have that common denominator. And same thing for the 10 over here, okay? All right, so that's going to look like this. 10x plus 2 all over x, okay? So again, I don't want to lose you on my first example. So just for clarification, that was 10 over 1. I went x over x. So now right here, I have a common denominator, right? They're all over x, so I can just say 10x plus 2 all over x. That's where that comes from, okay? All right, equals 8x over x. I have a common denominator and one fraction on each side. I can just pull out the numerators. Okay, it's the same conversation as here. If x over 3 equals 5 over 3, then x has to equal 5. If 10x plus 2 over x equals 8x over x, then 10x plus 2 has to equal 8x. Okay, so 10x plus 2 equals 8x. Now I want to solve for x. So I will subtract 8x from both sides. And I'm going to subtract 2 from both sides, okay? So when I take 10x and minus that 8x, I'll get 2x. And then when I subtract 2 here from both sides, I'll get negative 2. So 2x equals negative 2. Now I know that x will be negative 1 because I just divide both sides by 2, okay? X is negative 1. Now that I have the solution, I need to just go back and take a look at my NPV and say, hey, did I just get an NPV? No, I didn't. I'm totally good. So x equals 1 is for sure a valid solution. Okay? Awesome. Let's try another one. Okay, so the next one is m minus 3 over 2m plus m minus 1 over m equals 7 over 8. Again, first step is to factor. Nothing really going on here, so we're okay on that. I need a common denominator. My common denominator is going to be 8m. I can change all of these into 8m through multiplication, right? This guy here, I need to multiply by 4. So whatever I do to the bottom, I have to do to the top. This guy here, I need to multiply it by 8. Whatever I do to the bottom, I'd have to do to the top. This guy here, I'd have to multiply by m. Whatever I do to the bottom, I have to do to the top. Let's talk NPVs before I do that. M can't be 0. Okay, and then here I've gone, I multiplied this by 4. 2 times 4 is 8. Okay, I multiplied this by 8. And I multiplied that guy by m, just like I said I would. Okay, now I'm going to distribute these guys. So this is going to be, I can think about this all as one denominator on the left side now because it's common, right? So this is going to be 4m minus 12 plus 8m minus 8. Okay, 4m minus 12 plus 8m minus 8. Now I can simplify the top of that. 4m plus 8m is 12m. Negative 12 minus 8 is negative 20. I can also pull the numerators out because I have the denominators being the same thing. Okay. So I have simplified to 12m minus 20 over 8m equals 7m over 8m. I'm now going to pull my numerators out. Same reason for this guy, right? If x over 3 equals 5 over 3, then x equals 5. If 12m minus 20 over 8m equals 7m over 8m, then 12m minus 20 has to equal 7m. Okay? And so I get 12m minus 20 equals 7m. I will add 20 to both sides and subtract 7 from both sides. Okay, that's going to give me 5m equals 20. Divide both sides by 5, and m equals 4. Then I say, hey, is that allowed? I need to check that against my NPV. My only NPV was that m couldn't be 0, and so I'm good to go. Okay, my solution is m equals 4. Okay, good work, guys. All right, let's try this one. X plus 9 over x plus 6 equals 4. Again, no factoring to do yet. That'll come, don't you worry. But I do want to say that x can't equal negative 6. And then I want to actually have x plus 6 as my common denominator. So this guy here, I'm going to multiply by x plus 6 over x plus 6. This guy here, I'm going to multiply by x plus 6 over x plus 6. And that's going to leave me with x times x plus 6 over x plus 6 plus 9 over x plus 6, I didn't have to do anything to him, equals 4 times x plus 6 over x plus 6. Okay, so now I'm going to distribute the top guy here. X times x is x squared plus 6x plus 9 on that side. And then here I'll have 4x plus 24. Okay. I am now in a situation where I have a fraction equals a fraction and the denominator is the same, so I can just pull the numerators off. Okay, so I have x squared plus 6x plus 9 equals 4x plus 24. Okay, just in case my head's in the way there, I'm going to hide myself for a second so you can see that. All right, so now I'm going to subtract 4x from both sides and subtract 24 from both sides. I get x squared plus 2x minus 15 equals 0. I can factor that. I'm looking for two numbers that multiply together to give me negative 15, add together to give me 2. That would be 5 and negative 3. So x plus 5 and x minus 3 equals 0. Don't forget that equals 0, right? So that means I'm using the zero product principle. x equals 3 or x equals -5. I check those against my NPVs. The only thing that wasn't allowed was x couldn't equal -6. So both of those are good. There are two solutions to this one, -5 and 3. Okay, so we've got now in this next question, 2 over x minus 3 over x plus 1 equals 1. Again, first step is to factor. There's nothing to factor here. But now I'm going to look at my NPVs. So I know that x can't be 0 because of this guy. And x can't be -1 because that would cause a 0 on this guy. Okay, so x can't be 0 and x can't be -1. Now I need a common denominator. So my common denominator is going to be x times x plus 1. For this first fraction, I need the x plus 1. So I'll put an x plus 1 on the top and on the bottom to maintain the equivalency. On the second guy, I need an x. So x will go on the top and the bottom. And then for this guy, this is like a 1 over 1. So I'm going to need both the x and the x plus 1. So I essentially will have x times x plus 1 over x times x plus 1. Okay, so that's looking like this. Now I've got a common denominator here, so I can just put the numerators together. So that's going to be 2x times 2 minus 3x on this side. And then over here, I've got x squared plus x. Okay, so I have common denominators. I have one fraction equals one fraction. This is the point in time where I'm ready to pull the numerators out. I can say 2x plus 2 minus 3x equals x squared plus x. Okay, so I pulled the numerators out here. I might be in the way there. I'm just going to shut my head off for 1 second. Okay, and then I'm looking at just solving this now. So 2x minus 3x, that's going to be -x. So I'm going to add x to both sides, and I'm going to subtract 2 from both sides. Okay, so when I added x from both sides, x plus that other x is 2x. Then I subtracted this 2 from both sides, so that ends up with -2 on the other side. Okay, I'm now looking to factor this, looking for two numbers that multiply together to give me -2, add together to give me 2. They don't exist. Now, here's a great conversation because I'm seeing this in some of the tests that I get to mark. Kids are arriving at a statement like this, and then they say, oh, no solution because it's not factorable. That is not a true statement. Factoring is one tool that you get to use in order to come to a solution. But there are lots of other tools that you can use, i.e. the quadratic formula, i.e. completing the square. Okay, those are algebraic methods that you can do when you can't factor. Okay, so I'm going to take this guy and go straight to the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1, b is 2, and c is -2. Okay, so I've got -2 plus or minus b squared, so that's 2 squared is 4, minus 4ac all over 2a. Okay, inside the square root, I've got essentially 4 plus 8 there. So that'll be 12. -2 plus or minus root 12 over 2. I can now simplify root 12. 12 is 4 times 3. So the 4 comes out to be a 2. So I'm looking at -2 plus or minus 2 root 3 all over 2. I can divide everything by 2. And that'll leave me with x equals -1 plus or minus root 3. Okay, -1 plus or minus root 3. So there are actually two answers here. One of them is -1 plus root 3. The other guy is -1 minus root 3. Neither of those are the NPVs that I've listed, so both of them are good. There are two solutions to this question. Okay. Awesome. Okay, here's the first one I've given you, I think, today, where we actually have to have a little factoring to do. Okay, so let's take a look at that y squared minus 9y plus 18, looking for two numbers that multiply together to give you 18 and add together to give you -9. That'd be -6 and -3. Okay, so I've written this first and foremost in fully factored form. Now I'm ready to talk about my NPVs. I know that y can't be 3 and y can't be 6. And now I'm ready for a common denominator. Well, my common denominator is going to be y minus 3 times y minus 6. Okay, so this fraction over here is already taken care of. This guy over here, I need a y minus 6 on the top and on the bottom. And then for the second fraction in, I need a y minus 3 on the top and on the bottom. Then I'll have common denominators. Okay, so I have written the left side of my equation with that common denominator, and I put the numerator together right away. Okay, so it was this guy minus this guy. So now it's 9 times that y minus 6 that I needed, minus 4 times that y minus 3 that I needed. Okay, I have the same denominators, and I have one fraction equals one fraction. So that means I'm ready to pull the numerators. While I pull the numerators, I can multiply the 9 in here, and I can multiply the negative 4 into the second set there. So that's going to be 9y minus 54 minus 4y plus 12 equals 18. Okay. Again, not sure. My head might be in the way there. So let me just take me off for a sec. 9y minus 4y will be 5y. Okay. Negative 54 plus 12 is going to give me negative 42. Then I will add the 42 to both sides. I'll get 5y equals 60. And then divide both sides by 5. So y equals 12. Okay, I check that with my NPVs. The 12 is not one of my NPVs, so I'm good to go. I have one solution, and it's at 12. Okay, hopefully this is going okay for you. All right, 3 over x squared minus x equals 5 over x minus 3 over 1 minus x. Okay, a couple things to talk about here. I want to start factoring. I know that this is going to factor into, let me just circle that for you for a sec. This is going to factor into x times x minus 1. Okay, so let's just think out loud here for a sec. X times x minus 1. Over here, I've got 1 minus x. So the fact that I've got x minus 1 and 1 minus x, I also want to factor out a negative 1 from that bottom portion and make that x minus 1. Okay, that's going to make my life a whole lot friendlier. So that's what I have done right here. Okay, I factored the x squared minus x, and I factored out a negative 1 from this last fraction over here. Okay, now my common denominator then is going to be x times x minus 1. I don't need to deal with this negative 1 because I can actually bring it out to the front, and this negative with that negative is actually going to make a positive. Okay, so I've stated my NPVs. X can't be 0 because of that guy, and x can't be 1 because of that guy. And then I'm going to bring this negative 1 to the front, so that's going to be a plus there because I have essentially subtract negative 1. Okay. And then my common denominator will be x times x minus 1. So this guy's already set. I've got the common denominator. For this fraction, I need the x minus 1. So I'll multiply the top and bottom by x minus 1. And for this fraction, I need the x. So I'll multiply the top and the bottom by x. Okay, and I've already had that conversation with you that that's going to turn into a plus. So this is what I've done. Okay, I didn't do anything to the first fraction. The second fraction, I've multiplied by x minus 1 over x minus 1. And then this third fraction, I now have a plus sign because of this subtract negative 1 business. And I multiplied by x over x. Okay, so now I can pull these guys to be one fraction because they have the same denominator. So I can just add the numerators. So that'll give me 5x minus 5 when I distribute the 5, and then plus 3x. Okay. So now I have the same denominators. I'm ready to pull the numerator out. So I have 3 equals 5x minus 5 plus 3x. And then what I did there is I just stuck the 5x and the 3x together to be 8x. Okay, I'm just going to get rid of my big old head there for a sec. Make sure you guys can see that. All right, so now I'm going to add 5 to both sides. That'll give me 8 equals 8x and divide by 8. So I end up with x equals 1. check with my NPVs. Uh-oh, that is an NPV. Therefore, there's no solution. Okay, so no solution as x can't equal 1. Okay, super. All right, let's try a word problem. You know you want to. The sum of two numbers is 4. The sum of the reciprocals is 4 over 3. Determine the two numbers. So I'm going to call the first number x. So I'm going to say let x equal the first number. But think this through. If the first number is x, the second number has to be 4 minus x. Otherwise, they wouldn't have a sum of 4. So I know my two numbers are going to be x and 4 minus x. Now it says the sum of their reciprocals. So that's when I flip them. So that's going to be 1 over x plus, right? Sum is addition. 1 over 4 minus x is 4 over 3. So 1 over x plus 1 over 4 minus x equals 4 over 3. There's the equation I want to solve. I have everything factored already because there's nothing to factor, right? There's no greatest common factor anywhere or anything like that. So NPVs, x can't be 0 and x can't be 4. I need a common denominator, which is going to be x times 4 minus x. This first fraction needs the 4 minus x. Oh, sorry, I forgot about the 3. Great conversation. My common denominator is actually going to be 3x times 4 minus x, right? So this first fraction needs the 3 and the 4 minus x. The second fraction needs the 3 and the x. And then the third fraction needs the x and the 4 minus x. Okay. Getting everything to be a common denominator so that we can then pull the numerators out. Okay, so here I go. This first fraction needed the 3 and the 4 minus x. So that's what I've done. The second fraction needed the 3 and the x. So that's what I've done. And then the last fraction needed the x and the 4 minus x. And that's exactly what I've done. Okay, so now I'm going to work on cleaning this up. I want to switch colors of my ink since I'm already in pink. Just a sec here. So 1 times 3 is 3. And then this is going to be 3 times 4, which would be 12 minus 3x. This will just be 3x. And this will be 16x minus 4x squared. Okay. So that's what I got going on here. Now, negative 3x plus 3x is nothing. So that actually just leaves me with 12. And I can pull my numerators out because I have a common denominator there. So that'll be 12 equals 16x minus 4x squared. I'm going to bring these guys over here so that I don't have to deal with a negative leading coefficient. So I'm going to have 4x squared minus 16x plus 12 equals 0. We'll divide everything by 4, make my numbers a little easier. Okay, so I've got x squared minus 4x plus 3. And I'm now ready to try factoring. Two numbers that multiply together to give me 3 and add together to give me negative 4 would be negative 3 and negative 1, which means x equals 1 and 3. Okay, which actually is my two numbers. Neither of those are my NPVs, right? And so if I was to plug 1 in for x here, I get 1 and 4 minus 1, which is 3. If I was to plug 3 in for x, I'd get 3 and 4 minus 1, which is 1. So the two numbers, no matter how you look at them, are 1 and 3. Okay? The numbers are 1 and 3. All right, so that's it for this guy. Next lesson, we're going to deal with more of those word problems because we're going to do applications. But for today, focus on the equation solving aspect of it. Don't forget to talk about those NPVs and don't forget to check your answers against those NPVs, okay? You know where to find me if you have any questions. Please don't be a stranger, okay? I'm here to help. I will see you guys soon. Take care.